Hello, today we are going to talk about our Chapter 4 test review. So I'm going to go over the review and how I look at problems and how I want to solve them. So let's get started. Number one, which ordered pair is not a point on the graph y equals 1 half x minus 7? So what I need to do with all of these points is I have to test them, okay? And when I plug in the x and the y into this equation, if it makes the equation true, then it is on the graph. And if it makes the equation false, it is not. So I'm going to go through and test these. All right. I guess I'm going to start over here. And so in this first A, my y value is 6.5. So I'm going to plug that in for y. 6.5 equals 1 half. And my x value is 1 minus 7. So I'm going to bring down my, it's negative 6.5. There we go. So I'm going to bring down my negative 6.5 equals half of 1 is 1 half minus 7. And 1 half minus 7 is negative 6.5. And that equals negative 6.5, which makes this true. So A is not our answer. Okay. I'm going to do the same thing for B. I'll fit it in over here. And this is negative 8 if you can't see it. All right. And negative 8 equals 1 half of negative 2 minus 7. Okay. Half of negative 2 is negative 1 minus 7 equals negative 8. And hopefully you can see negative 1 minus 7 is negative 8. So this is true. So that is not the answer. All right. The next one, so I'm going to try C. And I can already see C is not going to be the answer, but if you can't, negative 7 equals 1 half times 0 minus 7. And that 1 half of 0 is still 0, and negative 7 equals negative 7. So that's not the answer. I do want to actually show you D so that you understand what it looks like when it's not the answer. 8 equals 1 half of 2 minus 7. Half of 2 is 1. 1 minus 7 equals 8. 8 equals 1 minus 7 is negative 6. Notice this is not a true statement. 8 does not equal negative 6, so D is not on our line. Okay? Let's take a look at number 2. F of negative 2, we call this the fancy type. That just means that we want x to be negative 2, so we're going to plug in negative 2 right there. So F of negative 2 equals 1 half times negative 2. Again, that just tells me x is negative 2. All right, and half of negative 2 is negative 1. So again, I'm doing that math. F of negative 2 equals negative 1. And really, it's a fancy way of writing our ordered pair. X is negative 2, y is negative 1. We just need to put negative 1 for our answer. Okay. Number 3, we have a graph here. We need to Jeremy's distance from home each hour. He is in a car trip. How many miles will he travel from home after 10 hours? Well, I need to find the rate of change in this graph. And I see that for rise over run is 50, so from 50 to 100 per hour. 50 miles per hour, rise over run. So that is my rate. That means in 10 hours, I will be where are we at here? 500 miles from home. If you wanted to write an equation for that, you'd have y equals 50x, where 50 is our rate, and we're going to plug in 10 hours there, and 50 times 10 is 500. All right? If you can see that, if you can think about the answer to that problem, that is good here. All right? If you're struggling with how I come up with that equation, remember you can still work through by saying, okay, he went 2 hours, he went 100, 3 hours, he went 150. Oh, he's going 50 miles an hour. That means in 10 hours, he's gone 500. That's actually a good way to think about the problem. Don't get too bogged down by the math. All right. Number 4, we want to know which one represents a linear function, which means this has in a pattern. Both the y and the x have a pattern. Okay. That's through addition. So I would add 2 to get from 8 to 10. I would add 2. and I would add 2. So it looks like it could be linear. All right, and I'm going to come up here. 5 to 3 is -2, and 3 to 1 is also -2, and 1 to -1 is also -2. So the rate of change here is the change in y over change in x, or 2 over -2, which is -1. The simple fact that it has a rate of change, a constant rate of change, tells me that yes, f is linear. And I'm just going to show you one that's not linear. So for example, from here, 1 to 4, I'm adding 3, and then 4 to 9, I'm adding 5. Okay, and here is adding 2. So this stays constant, but this is not the same. So G would not be an answer. I'm just going to show you one of those why that's not an answer. Number 5, in class, I did not read this problem properly. We are comparing 2 different cell phone plans. And we have the first plan costs 5 cents per minute. And then the second plan is represented here in this table. Okay. We want to find and interpret the rate of change in y-intercept. Well, the rate of change in the first plan is 5 cents per minute. And since there's no y-intercept, there's no plus whatever, plus 5 or plus 10, that means that there is no initial value. So this plan is free, but then 5 cents per minute. All right. Now, the second plan, 20 messages cost $10 and 30 messages cost $11. So we're changing every 10 messages costs me $1. Okay. So that's $1 per 10 messages, which is 10 cents per message. All right. Now, I'm going to work my way backwards here. So if I wanted to go back to 10 messages, that would cost me $9. And then working back to 0 messages, so again, I'm counting by 10, that would be $8. Okay, so this plan costs $8 up front, and then 10 cents per minute after that. Okay, and so this is my rate of change for plan 2. And this is my initial value, the $8 upfront cost. So you'd go into the store, you'd pay $8, you might get a phone, and it costs 10 cents per minute for a text. And then this plan is free upfront cost and only 5 cents per minute. So obviously the first plan is a much better plan. All right, which of the following represents a non-linear, does not graph a straight line? And this really talks about the last 2 lessons we covered. Remembering that when we graph something like x squared, that graphs a parabola, okay? And that's not a straight line. So this is the nonlinear. Notice all of the x's in these other equations are x to the first power, and anything x to the first power graphs a straight line. So our answer here is G. Okay, turning the paper over. Number 7, Nate has a certain number of songs on his MP3 player. Each week, that sounds like a rate of change to me, he plans to add 2 more songs, so 2 songs per week. And then after 5 weeks, he has 25 songs. So what I see is a rate of change or a slope, so that's our M. I see an X value, and I see a Y value. So this goes into our Y equals MX plus B type of problem, where we know 3 of the values, and then we're going to solve for B and write our equation. So my Y is after 5 weeks, he has 25 songs. Okay. He is adding 2 songs per week for 5 weeks. So how many did he start out with? All right. 2 times 5 is 10. I'm going to subtract 10 from both sides, and I'm going to get 15 equals B. All right. And that means he started with 15 songs. Okay. Again, he added 2 every week for 5 weeks. All right. The domain and range, this is simply a vocabulary question. Domain are the X values. So domain is -4, 1, 0, and 3. Okay. That's the domain. And my range is the 4, the 2, the 3. And you usually don't write the range twice. So 2 is listed twice. I'm just going to write it once. All right. Now, for number 9, they're giving us the points to use, -2, 0, 1, and 2. We're going to plug them into this equation and get the output, get the y. Remember, this is fancy for y, so if you don't like it, you can just figure y there. All right, so I'm going to plug in -2 for x. So -2 times 2 times -2 plus 1. -2 times -2 is 4, and 4 plus 1 is 5. So that is my first one. All right, and if you remember, the slope is how this changed. So this is going to be subtracting 2 every time, but let's see it. Ooh, we're counting by more than 1 here, so this will appear to look different. I plug in 0. -2 times 0 plus 1 is 0 plus 1, which is 1. Then I plug in 1. -2 times 1 is -2 plus 1 is -1. And then at 2, that's this 2, plus 1 is -4 plus 1, which is -3. So when we are counting by 1, you'll see that it changes by -2 every time. It gets 2 smaller. The reason it jumped so far here, it jumped 4, is because we're counting by 2 here. All right? Number 10, we're going to write a function that represents this situation. Grocery store sells cantaloupes for $4.50 a pound. So we could say the cost of a cantaloupe also starts with a C, so I'm just going to use X, is going to be $4.50 X. I guess I could use W for weight. That probably would have been better, but it really doesn't matter. All right. Is this function continuous or discrete? What we want to understand with continuous and discrete is in a continuous set of data, are points in between. So if I actually graph this, I might say pound 1, pound 2, pound 3, and then I'm going to count by $4.50, $9, and then what's that? $13.50. All right. So I graph those points, and then what I notice is that, you know what, I could have a cantaloupe that weighs 1.5 pounds or 1.25 pounds or whatever. Any weight I could theoretically come up with. So all of the points in between our main points make sense. So we would connect the dot. That means this data is continuous. Okay? If it's discrete, like maybe I'm selling junk cars for $500. I sell a car, I sell 2 cars, and I sell, 500 or 1,000. The points in between don't make sense because I'm not selling half cars. So I can only go from 1 and then jump to 2 or jump to 3 cars, right? I'm not selling half cars or quarter cars, and that data would be discrete. But in this problem here, this is continuous, okay? And then the very last one, number 12, couple ways to look at this. All right, we can make our table. All right, and we can graph it. So we could say -2 squared is 4, and 4 minus 2 is 2. -1 squared is 1, and 1 minus 2 is -1. 0 is going to be -2. 1 squared is going to be -1, and 2 squared is going to be 2. So I just plugged the x values into here, and we would plot those. The other way to think about it is find your where we start. So we move down 2. Okay, and then we can think of it as 1 squared is 1, and 2 squared is 4. 1, 2, 3, 4. 1 away from my vertex is 1, so 1 squared is 1. 2 squared, 1, 2, 3, 4 is 4. And you can see that these match our points that we use when we plug the numbers in. Sorry I ran that last example a little quick, but I am running out of time. So I hope this review helps you, and I will see you guys next time.